Hey guys, hopefully you are doing well. Harry here, and welcome back to my channel again. So today video is about data analysis, and this is our third video where we're gonna talk about exploratory data analysis and machine learning algorithm. Right, guys? You can see in front of your screen, you have a data set, right? So our data set contain let me walk you through this first, right? So our dataset contains 1 2 3 4 5 6 7 8 9. We have 9 columns over here. First we have a branch name, which is basically a store. Second we have the week. Third we have a day week. Fourth we have day. Fifth month. 6 hour. And 7 transaction type, which has card and cash. And we have unit is about like how many units of product does a customer has purchased in our store. And at last we have amount. So amount is in dollar. And the different over here is positive and negative value. Positive defined your card payment, where negative defined your cash payment, right? We will analyze this data. We will check all those pre-processing technique to see is there any missing value, right? Then we will do exploratory data analysis to see the chart, and which will basically tell us the trend. Then we will go through the machine learning algorithm, which will help us to make a decision on the base of our prediction. And same time we will use a truth table ROC curve to evaluate our model, because this is more about the classifications model, because we have transaction card and cash, where we're gonna convert one of them into 0 and 1 into the 1 to see the customer segment. If you are from data analysis field and you are familiar with the Python, and you are learning right now how to use the machine learning algorithm, you can really understand me. But who are new in this section, so I'm gonna code in front of you, and I'm gonna teach you each of the step, and I'm gonna tell you what that step mean on our data analysis. And same time, guys, I will walk you through all my previous project which I have did since last 2 years, right? So I will make more video on top of that, so you guys can easily understand how to use a machine learning algorithm, especially classification and regressions, right? Our goal of this video is to make a firm decision about how the customer behave into our store, right, guys? So this is a data from Kaggle. This is a random data. I will provide on the link below the description. So now, guys, it's time for to use our Python knowledge and statistics knowledge, right, guys? Let's move on. Let's move on, right? Right, guys, first thing first, today I'm using a Jupyter notebook. I'm not using Google Colab, right? So similarly, to get more coding block, you're gonna press outside the block and you're gonna press A, right? The more you press A, it will give you the more coding block. So if you want to delete this, I'm gonna press on the top and press D, right? It will delete the bottom, not actually the bottom one, the selected one, right? So yeah, I'm gonna press A, and I'm gonna make this into a markdown cell. For making this into a markdown cell, you will press M, right? I'm gonna write the heading of the project. I will say project. Oops, sorry. Project, right? I will say store sales, right? Analysis, right? I'm gonna press 2. That will give me the amount of the heading I want. Let's say when you are coding on web development, you have a h1 tag, h2 tag, h3 tag, which have a different header. If I press 1 and I press shift enter, it will give me like the highest let's say h1 tag over here, right? Similarly, if I press 2, and it will give me the second one, right? And I press 3, and it will give me the third one. So I'll stick with the 2 that look quite decent, and I'm gonna write my name over here, right? Because this project belong to me. I'm doing in front of you, so I'm gonna press M and press shift enter, right? So let's say this is my project. That's how you're gonna write your project title and your name, right? So I don't want to write a table of content right now, right? You can write this after uh I mean like over here you can write this table of content, and you can write all the step you want to show over here, right? That's how you can present your project while you convert this into a PDF form, right? But right now, what I'm gonna do, I'm just gonna do some block coding. I'm gonna show you what are the step-by-step process, right? So let's stick with loading our data set and loading our library, right? So first thing we have to do is to load our libraries, right? So libraries, right? So there's a cursor on the top, so I can't see, right? So now I can see. I will say library. Oh, sorry. Uh, Loading libraries. I am just gonna press 4 tag, right? So I just press the 4 over here with the markdown cell, right? So I'm gonna import the libraries. I'm gonna say import simple libraries. It's gonna be numpy as np, import let's import pandas as pd, import seaborn as sns, import matplotlib dot leave. Oops, sorry, matplotlib dot pyplot as plt, and I'm gonna import warning dot filter. I'm gonna press tab. No, it's not giving me anything. Warnings, I'm gonna be ignore. So after ignore, we will say, oops, sorry, I forgot to import warning. So this will basically filter out all those unnecessary things, right? So I don't want to go through all of this because I don't want to waste your time. So look like there's a spelling mistakes. There's not to be s. Okay, that's cool. So now we have imported our library. Second, I'm gonna like loading data set. So gonna press 4 again outside the cell, and I'm gonna press shift and enter, which is gonna give me a markdown. That is our second task, loading our data set. I'm gonna name simple df for data frame pd dot read csv, right? So I need to load this data set, um this one, right? Store. Yeah, just gonna copy, and I'm just gonna paste over here dot head. So guys, I have load my top 5 rows over here. Now I'm gonna say df dot tail, and I can see the bottom 5 over here, right? So yeah, so first task is done. It's loading our library and loading our data set, right? Right, guys. So another step is pre-processing, right? So on pre-processing, we're gonna check how our data set is basically look like, right? In the form of our data types, in the form of our missing values, or they have any missing values. We have to look after what type of missing values. So in my previous video, I forgot to mention you about because the video was quite long, so I forgot to mention about missing completely at random, missing at random MAR. So this is MCAR, this is MAR, and missing not at random. About this three topic when we are looking in our data set, right? So I have one document which is known as the treatment of missing data, right? This is by David C. Howell, right? Hopefully I'm not mispronouncing your name, and my apologies if I mispronounce your name. And it's from University of Vermont, right? And this document is quite interesting, so it will guide you through all the missing completely at random, missing at random, and missing not at random, right? So these are uh, how to deal with those kind of data set, right? So what kind of application we should imply over there, right? So guys, I'll provide this document in my GitHub repository, and same time I'll provide the link over there, right? You can go through this. So yeah, let me give you a little bit overview about this. Missing completely at random, right? I have actually wrote a point over here. Imagine you had a survey, right? So you basically imagine you hand out a survey, and some people forget to fill a age question just because they didn't see it. This could happen to anyone, and this is not related to their age or any other factor in the survey. So why it is MCAR? So because the missing age data has no pattern and isn't influenced by the age of the person or any other information, right? So you can safely ignore or remove the missing data, knowing it won't affect your result because the missing data is random. So you can just remove those columns from there, right? So missing at random, which is MAR, let's say in a job satisfaction survey, higher paid employees tend to skip the salary question. However, their job title and satisfaction score are still available. which give clues about why the salary is missing, right? So this is quite interesting, right? Let's say employer is paying employee a salary, and employee is making quite good salary over there, right? So an employee try to skip that salary, employees try to skip their salary survey over there, but you can see their satisfaction score and of course the job title. So basically you can impute those missing data with calculating the other employees or type of job, salary, or the satisfaction score the other employee has made if some employees has skipped those questions. So you can impute those values into those employees name, right? So it's like we're gonna treat an average value, we're gonna sum all of those employees value and divide by the number of observations, and we're gonna impute those value into the missing value of the salaries, right? And same with the score, happiness score, let's say 1 to 10 or 1 to 5. We're gonna take all those same job title employees, and we're gonna sum all of them and gonna divide by the number of observation, which will give us an average value, right? So that's where we can impute there. So why it is MAR? The missing salary is linked to the other variables like job title or job satisfaction, but it is not directly related to how much money the person makes. Yeah, that's also makes sense, right? You can use those other variables, job title, satisfaction score, to estimate or predict the missing salary values. By deleting the data might lead to biased results, so using imputations or modeling is better. So we're gonna use the average value as an imputation, we're gonna use a mean value as imputation, right? So but remember one thing, we're gonna look after the same job title, and we're gonna of course they need to have a same job title over there, right? And which will give the where we're gonna look after their salary and their satisfaction score, right? So missing at random, MNAR. In survey about alcohol consumption, people who drink a lot may leave how many drinks per week, right? So a lot of people drink, right? So I don't know how many people drink, and lot of people, they don't tell the truth, they drink, right? So let's say question blank because they don't want to reveal the truth. Yeah, that's mean like the people drink quite a lot. So why it is MNAR? So that's a big question, right? Why is this missing not at random? So the missing data is caused by the fact that the people who drink more are likely to hide their answer. So it's directly linked to the value, the drinking habits. Okay, that's a drinking habit. So this is the hardest type of missing data to deal with. You might need advanced technique or even external data to try and understand the missing value, or you could conduct follow-up to get more information. So in this type of data, if you are dealing with, let's say we are dealing with the medical data, right? So in medical data, we want to be very accurate, right? So if somebody has a health issue, so we actually have to follow up and reconduct the surveys, then where we can make more informed decision, right? So the best thing over here is like we can completely work out, we can exercise with missing at random, missing completely at random. So we can remove those columns, right? If we don't need those columns, if those column is not that much important, right? But missing not at random is more about qualitative survey. We have to actually approach that person, and of course like we have to make a more survey, or we have to go through the more documentations or more previous data to make some conclusion over here, right? So guys, hopefully you understand about the missing complete at random, missing at random, and missing not at random. So first thing I'm gonna do is I'm gonna check the information of the our rows and column, which will be rows and columns. So I'm gonna say df.shape. So I'm gonna shift enter. We have 4100 rows and 9 columns. Then I want the information of our data types. Let's say data types of our columns. So information mission of each columns data types. So I can write it like df.info, open and close parentheses, then shift and enter. Oops, sorry, I forgot info. So that's give us information. You can see over here we have same 4100 row, and we have 9 columns. It's basically both are same. Now branch name, that is the object, which is basically our string, and Wix are our numerical value. Transaction is our string. Same, we have a numerical value and we have a string over here. Okay. So next thing we can do is df dot is null dot sum. So now we can see we have a 0 missing value in our data set. So we're gonna say checking missing values, right? So we don't need to sum all of them to check how many missing on each columns, because now we know that we have 0 missing values over here, right? So but one thing we have realized over here, the amount column, right? The amount column is an object. So you can see the amount column is an object. It's basically a string. So we have to treat this as a string right now, but we have to convert this into a numerical value, which can be float or an integer. Integer is something which don't have dot 00, but you can see still over there we have 17.80, so we have to convert this into a floating point number. So floating point number is basically a decimal point number, right? So converting, let's say converting amount columns into numerical value. I just gonna make a simple comment which will basically define what we are doing over in this block, right? Okay, so now what to do, right? So what is the first thing or first move we should make over here, right? I'm gonna select amount, right? I'm gonna select amount. I'm gonna iterate through the amount column again, right? So I'm gonna use a dot str, right? That's the str method. I'm gonna replace oops, sorry, my cursor is here. Now you can see this replace, replace, and I'm gonna replace with uh, let's say dollar sign with a space, right? Then I'm gonna say dot str, right? uh, okay, so dollar sign. Okay, so let's try this first, right? df dot head. So okay, so now we have replace our dollar sign with the space. If I can remove the space and just make without the space, okay, there's no white space now, right? So our next thing is we have to convert this into a numerical value. So now we have removed the dollar symbol, right? So uh let's check into the other unique stuff. So df dot unique. Okay, if I can iterate through at least like 50 of them. Okay, does look fine. Maybe 100 of them. Okay, does look fine. But I can go through the minus 100. Okay, does look fine. Okay, now you can see over here, uh, everything look fine. So I'm just gonna look after the white space again, right? So let's say gonna iterate through them again. df amount dot str dot replace. I'm just gonna remove the white space. So let's try to remove if there's any comma over there or any symbol. I will stick with the comma. So you're gonna just use the same process again and again. So it's not really difficult. So you're gonna use a string method and you're gonna use the same process again and again. Okay, so that's look fine. If now I can say like df dot amount equal to df, sorry, amount dot for that we have to convert this into s type, let's say float, gonna shift enter. So look like it's actually worked. So I'm gonna double check again. Df amount dot d type. So now it has been converted into a float, right? So now you can see over here, it was on the top, it was basically your object. Now the object has converted into our float. So I will say df dot info. I'll give you the overall demographic over here. Now you can see the amount is a float form, and say df, if I print 5 of them, so amount is in a float now, right? So that's cool. I'm just gonna delete this again. I get more block over here, right? So our next step should be to check the duplicates over here. If we have any duplicate rows, I will say count. Oh, sorry. I'm just gonna put this all into a single block so that it's look nice, right? I'm just gonna remove this, I'm gonna say count. Uh, wait, hold on. Just look better. df dot head. Okay. So count the number of duplicate rows, right? So for that, we're gonna do simple df dot duplicates and dot, sorry, open and close parentheses. Sorry, duplicate it, open and close parentheses, dot sum, and we're gonna just run this. We have 0 duplicate, right? So now what we're gonna do is we're gonna do some statistical analysis, right? So we're gonna check after some statistics, right? So statistics. So summary of statistical analysis. So we're gonna look through some statistics over here. So df dot describe, open and close parentheses. Now you can see over here, so we have mean, right? Average amount spent in the store is $35, and we have count of those average spent. Let's say we have, sorry, we have overall count is 4,100, but our average spent is this, and the deviated standard deviations is 183.53, right? Those are our quartile, and our maximum is $1,487. Okay, so that's cool. Let's move on. Our next step should be to check the statistics of categorical column. Right, so I'm gonna type df dot describe. So open and close parentheses. Just inside of this, you will write include, right, equal to. Then you know, in a quote, you will mention over here object. Now you can see over here it says transaction 1400 unique 2. We have card, we have maestro, right? So card is 2008 2811 frequency, right? So that's are the statistics we have got over here, but that doesn't make any sense, right? Doesn't make any very strong sense. But what we're gonna do next is count the unique value in each columns, right? So count unique value in each columns. So it's gonna be df dot unique, open and close parentheses. Okay, uniq, sorry, and I have to write NUNIQUE, right? So now you can see we have a unique branch is 1, which is basically my store. Let me show you. Hey guys, so finally we are in our EDA session, right, which is known as exploratory data analysis. So now we're gonna move into a little bit advanced topic, which is about data visualizations. So in these visualizations, you will understand how our data set look like in the term of the columns and rows. So basically we're gonna look after the columns, right, because we're gonna plot some normal plots such as line plot, bar chart, and of course like histoplot, and sometimes we also have to plot the scatter plot. So this time is more about the histoplot in this coding section, where I will teach you more about the histoplot, how to look after the histoplot, especially it's a normal distributed curve or it's a skewed curve. So hopefully you will have some technical understanding about how to do the data visualization after watching this video, and gain some statistical knowledge, right? So guys, let's move on. Right guys, so let's me walk you through some of the histogram plot, right? So I have just typed the random histogram over here. Now you can see there's a lot of histogram plot, you can see. So okay, so let me open this one. This one look really nice, and okay, so this one can show over here, right? So this one is a normal distribution plot, right? This is the right skew, sorry, this is the right skew distributions, and this is the left skew distributions, right? So right one is like basically they have a right tails over here, left skew have a left tail over here, right? So uniform distribution is like is basically have a constant distributions, right? And now we're gonna move into the unimodal distributions, right? So this is a normal distributions, right? So unimodal, symmetric, the bell curve over here, right? Then another is the symmetric bimodal distribution. So there will be two bell curve over here, right? Here will be a unimodal because it will have a single bell curve. It will have the two bell curves over here, right? So non-symmetric bimodal distribution, right? So you can see these are non-symmetric. Here we have exactly symmetry between these two bar over here, right? On our histoplot, what we can say number of frequency count in a definition side, well defined form, number of frequency count on this side and this side are equally distributed. Over here you can see there is no equal distribution pattern over here, so these are non-symmetric, right? Okay, so even you can see over here uniform look like this, left skew like look like this, symmetric unimodal look like this, these are bimodal, these are multimodal which has multiples peak over here, and same these are right skewed, right? So I'm just gonna cross all of this, and I'm gonna write a function which will say def. So I'm just gonna zoom this so you guys can see better. So I will say define function, I will say that's basically a def, right? So define function histoplot, and I'm gonna take an input as a data frame, and I'm gonna take a column, right? And I'm gonna take a title. So these are our parameter. So open and close parentheses, then you have basically the column over here, and then we'll say df, then we're gonna iterate through those data frame with the help of the column, right? And I'm gonna say dot plot. So plot is the function from the matplotlib, and I'm gonna say kind. The kind will be the type of plot I'm expecting, that will be histo, and gonna be bin. So bins 20, that's a bin width, and alpha will be like how much transparent, or how much transparent, or like basically like what the color gradient you actually looking for. You're looking for like little bit transparent or little bit more darker, so this will define by the alpha. So I'm gonna put the alpha into a 60%, then I'm gonna define the color. So I would love to have right now something like blue. Okay, so I'm gonna make a mean value, I'm gonna make a mean line. So a mean line will be defined in the plot. So the mean value will be something like df. So data frame with the column, same we're gonna iterate through the column, column, then dot mean, open and close parenthesis, that's a function to calculate the mean. Same with the median, with the middle value. So I'm gonna use a snake case over here. You can see df column, so gonna be median, open and close parentheses. So the first one will give us a plot, right? So plotting histoplot, right? Calculating mean and median, right? So we have made two application over here. One is to calculate the one is to show the plot, second is to calculate the mean value and the median value. Now I'm gonna put a title, oh sorry, title of plot. So title of plot will be plt dot title and title. So you know that the title will be replaced by this parameter over here. This parameter, whatever the string value will define, it will reflect on this one, right? So the functions, right? So we are actually using a functions over here. So plt dot x label, right? So that will be column. Plt dot y label. So basically, when we look for histoplot, we count the frequency, or you can say number of count. It will make more easy and more precise to understand. So I will use the Excel line. So plt dot ax vertical line, and it will be mean value. Oops, sorry, mean value. Then I'm gonna define a color. Color will be black, and line style. Oops, sorry, line style will be dash line, and let's say line width. Line width will be 2. You can say line style as ls, line width as lw, but I would like to keep it more well defined, because the understanding is more important than taking shortcut right now. So mean value again. So this is the text. Text basically, when we have a line, the mean line which is defining in our histoplot, there will be a text will be reflecting which is showing the value of the mean. So that's why we're writing this code plt dot text. So mean value, so then mean value, let's say plt dot gca open and close parentheses dot get, right? So get y lim open and close parentheses. I'm going to index 1 into 0.9. So this will give the configurations. And let's say I'm going to use f string right now. So f string to define what is the value of the mean. So the mean will be mean value. Then I'm going to take a 2 round off figure. I'm going to be color in the text of black. Right, so there's some mistake over here. Color, right? So I forgot to use the curly braces, close curly braces. So color, oh sorry, I used this quite fast. So f string, so code inside the code. So let me double check. So main value plt dot gca open close parentheses dot get volume open close parentheses. Then I have index into 0.90%. And we have the main value, and we want that color text into black form, right? So then I have to write one more code for our, I'm just gonna copy this, right? So I'm gonna paste this, just gonna do some scripting over here. Instead of mean, I will write median, and same with this one. I'm gonna paste over here, and if I can put my cursor over here and can press control and put the other cursor over here, I can change both into the same time. MEADIAN, MEADIAN. That's look fine. So I'm just gonna keep this on red color, because I cannot keep both into the black color. This will cause a lot of confusion while reading our data. Okay, so we need a grid line, because I love plotting the grid line. So sorry, plt dot grid, and I will say true. That will let us to use a grid line, and say line style will be dash dash dash. So this is the line style over here. What? Okay, that's need to be twice, not thrice. So yeah, line style dash dash dash, right? So over here I have used line style dash dash, right? So you can say that's a short form of line style ls, and we can also type like this way, DASHED, right? And we can also type over here DASHED. You can use the both method are fine. So alpha equal to 0.3, that will give us a faded line. Okay, color, that will be gray, right? And I'm gonna say plt dot legend and say plt dot show. Okay, so something is invalid over here, so I need to quickly inspect this. So df plot k and a hist bin, so it says forgot the comma. Okay, I forgot the comma over here. There we go. Right, so I'm just gonna make a comment over here, title of plot, and let's say title of axis, and I will say mean and median, mean and median line with text, right? As this is great line, and oops, sorry, and this will give basically this will give a label of data. Okay, so I'm just gonna run this again, right? So let's revise again. We have defined a function known as histoplot. We have three parameter, which is our data frame, our column, the column which we are iterating through, then the title, right? Then we have histoplot. We have defined a histoplot. Then we have defined a mean and median value. Then we have defined the title of the plot. Then we have defined the axis. After axis, we have defined those lines, mean and median lines. Then we have plotted a grid line. Then we have defined the title of the label of our data. If we have a scatter plot, we will say label of our data points, right? So I'm going to use a function now, and I will show you what I'm going to do over here. I'm going to use a function now. Inside the function, I'm going to define two of those, right? So I'm going to define the two of those. I'm going to define first, right now I'm going to define hours, and uh, basically I'm going to define this all data frame. Then I'm going to define the hours. I want to see how this column pardon me, how this all the column uh, of this hours will look like when it is distributed, right? It is basically normal distributed or it is skewed, right? So it's uniformly distributed. So we're gonna have a look, right? So I'm gonna say histo plot, right? I'm gonna say data frame as a data frame. Then I'm gonna define hours, hour, sorry. Then I'm gonna define the title will be distribution of hour. Open and close parentheses. Okay, so histplot. I have wrote an extra over here. So histoplot. So now you can see over here is gave us a distributions of the hours, where you can see there's a mean and the median, right? It's almost closer to each other. And you can see the number of count, which is basic the frequency. The reoccurring number is being accumulated all together to give this plot, right? This data look like little bit of bell curve, but it's not that perfect bell curve, but still look like little bit. So okay, so there's something we want to make a change is on the mean and median value. They are clashing each other, right? They are overlapping. So this is called overlapping effect. So I'm gonna make this little bit down 0.70% to the median value. So now median is a little bit down over here under form of text, right? So that's look much better, isn't it? So I'm just gonna zoom out. That's look much better. So our mean, that's the mean. Oops, mean value. I have to make because I have made a basically I was scripting. Because of the scripting, I forgot to change the name of the app string, median. So I'm gonna run this again. Now you can see over here the mean value is 12.95 and the median is 13. So the mean count of the hour is 12.95 hours, where median is 13 hours. So that's way we had made an analogy over here. So customers spend nearly about 12.95 on the mean hour, where the median hour is about 13 hours. I'm like middle hour, right? So that's actually the middle of our data set. So they look they are pretty much near each other. Let's see how mean and median look in normal distribution plot. Okay, So when there's a symmetrical distribution, right? So when we are looking after the symmetrical distribution, I'm just gonna zoom this. The picture is not that much good, but still you can see over here. Symmetrical distributions has mean, median, and mode on the middle, where skewed distributions has mean first, then you have median, then you have mode, right? So that's mean this is quite symmetrical distribution over here. Right guys, so let's move on into another one. So another one is I'm gonna use the same histoplot for the units and the distribution of units. So I'm gonna say, I'm just gonna copy this. So to save our time, I'm gonna do scripting again, units. So guys, only do scripting if you are well equipped with your foundations of the Python programming and of course the uses of the library. So if you are still learning on the process, please don't do what I'm doing over here, right? Please follow the process. There is no shortcut, right? So I'm just gonna shift enter this. So now you can see over here the data is quite skewed. You can see there's a mean, median, right? So I'm gonna do again how mean and median look in skewed data. Okay, so this look like a perfect example. If I can just take this one look much better. So now you can see over here we have skewed data. We have a median first, then mean. So now you can see over here we have median then mean. There's no clarity. So yeah, this one you can see over here we have median, mean, and mode, right? So there's the median first, then we had the mean, right? So now you can compare this again, median first, then mean, right? First median, that's the red one, then mean. So that's mean the data is skewed, right? Okay, so another one is we're gonna do with the amount. Take amount, uh amount, right? I'll say, okay, so now you can see the amount one. So the amount one is quite uniformly distributed, but have the curtices, right? So you can say like, let's check into kurtosis curve and mean median distribution. So now you can see over here. So now you can check over here. This is the highest peak value over here. The most occurring value. The mean is 35.24, and that's look like more about like leptokurtic distributions. Between the leptokurtic and mesokurtic distributions, because they have a very peak value over here. And yeah, that's the one. And you can see over here this is not a perfect because there's a little bit skewed over here. You can see over here it's a little bit skewed over here, this area. That's why the median is over here and the mean is over here, right? So the average spending, let's say the average spending over here is minus 2.38, because this is skewed data, right? We will consider mean, but we still have to consider middle value, because the middle value will be more appropriate to use this rather than the using a mean, because the data is skewed. But I will still say 35.24 is not a bad spending. People do spend like $35 in a store where the cash is like $2.38. The negative is for the cash payment. Hopefully you remember the cash payment was negative, card payment was positive over here. And over here also you can see like median is 8 and the mean is 12.78. So if you are building a market strategy, then the average spending of your customer is $2.38 to 35.24, let's say something like that. And at the same time the number of count of the product, basically the amount of the customer purchasing should be 8 to minus 12.78, right? So those are the between the units the customer can buy, right? On an average the customer gonna buy that, right? And of course the hours, the spending hours of there is 12.95 to 13, right? And it depend on the hours. I don't know how the data set is defining the hours. I don't have any clarity in this. The hours can be like, oh, in weekly they are spending this much, maybe monthly they are spending this much. So yeah, this can be anything. So all we have is the pattern over here. So next thing what we can do is we're gonna move into our line plot. So I'm just gonna do one more scripting. I'm just gonna copy this to make our process fast because the video gonna be quite long. So I'm just gonna uh, say over here something like line plot. Okay guys, so let's move into the line plot. Right guys, so first thing first, in our line plot, hopefully guys, you guys know about the time series analysis, right? So time series doesn't mean only for the stock predictions, but also people use time series to predict their sales, normal, their selling their services or selling their products. So you can see how this chart look like in internet. There's a sales and there's the year, right? And you can see the trend going on the upward trend, right? But it's a cyclic waves over there. So guys, we're gonna make a one of this chart, right? But our chart gonna be same like this because it's gonna be gonna tell us is our product is going upward trend or downward trend. It's depend on the data, right? So but this data is quite huge. It's since 1950 to 2020, so we won't be having this kind of perfect uh like the cyclic wave or like perfect sales plot they have mentioned in the Google, right? So we're gonna use our same data line plot to design such sales trend, right? So I'm gonna say df, right? I'm gonna see the 5 rows. So what we're gonna select first, uh, we're gonna select our let's say per day sell, right? So we're gonna check how much each hour per day sell. So for that I have to sort them into such a way that it should give me those per day sell, right? So I will say, so I will show you. We are not gonna use any let's say any date over here, but there is a day 2, day 1 in our data set. So let me show you. Now it's really cool to if I can show you this unique code, right? So df and we're gonna iterate through our column day. Then I'm gonna use unique. So open and close parentheses. Now you can see over here we have unique 2, 3, 4, 5, 6, 7, 8, 9, 10 till 31, right? So these are the days we have. So we're gonna accumulate all the value over there and we're gonna make those plots, right? So let's see how this plot look like. You can use a bar plot, but I'm gonna use a line plot because I want to make it more as a time series where we have a days and our y-axis will be more like our units, right? So you can see this plot. Similarly you can imagine the top one, let's say this one, right? Similarly after using this data frame, right, in our days will be in our x-axis where our units, not amount, right, units will be in our y-axis, right? Because amount is in a cash and card, we're not considering them, we are just considering the our days and unit, right? So for that we're not gonna use any function. We have to do a manual coding over here. I will try to save as much as time, right? So I will gonna do some scripting from our the same code I have used inside the function, right? So I'm gonna use the scripting, so I'm just to save time, and I'm gonna explain all of them at the end of the block, right? So okay, so first thing I'm gonna do is like make a day unit sum. So I will say day units sum, right? Df. So I'm going to use a group by function, group by, and it will be like day inside open and close parentheses inside the code. Then I'm going to go through the units. I'm going to iterate through the units dot sum open and close parentheses, then reset index, right, and open and close parentheses. So this will give me, let me show you, this will give me the sum of those days according to unit, right? So first day we have sold this much unit, you can consider like that, right? If I say dot plot, so it will give me a line plot, right? But the thing over here is I don't want this blue line plot over here, I just want one single line plot. So I'm just gonna remove this. So on the bottom of this same block, I will write over here plt dot plot. I'm gonna just write day and gonna press tab, so it will give me the statement. And let's say I'm gonna iterate through the day into my y-axis, right? I'm gonna do same. It's gonna be units color equal to red. Right, so now you can see those are the days and those are our units. So I'm gonna copy this again, gonna paste this again over here, and I will say scatter. So that's the scatter plot, and the scatter is on each of the peak value over there, and I will say something like black. So this will look a little bit nice. I will change the size of the scatter. I'll put as for the size equal to 20. That will give a little bit small size. And what I'm gonna do, I'm just gonna take some code from here. Grid line. Let's see, grid line, legend, and this, right? So I'm just gonna paste over here. Oops, sorry, I forgot to make those. Uh, Press those tab button over here. And okay, that's look a little bit fine because we have a grid line over here. Let's make a little bit decent. I'm just gonna copy this title, X and Y label, and again I'm gonna do some scripting over here. Right, let's say Y label will be unit sold, and oops, sorry, I made a mistake over here. So that's need to be your Y, X need to be your days, right? So we have days and we have unit sold. Then we need a title, right? So I will say plt dot title, and I will say total unit sold per days. So okay, that's look fine. And you can say over here something like label units sold. Yep, that's a unit sold. So guys, what we can learn from this chart? So from this chart, we can learn that the maximum amount of sale we have made was during the between the day 5 and day 6, right? We had the peak value around 2,200 unit, and the minimum or the minimum amount of sold we have made on the end of the month, which basically showing we are going downward in our sales uh, between these values 25 to 30, right? There was a quite hike on this area, 25 to maybe 26, 27, right? And 28 to 29 was also quite decent sale, but after the 30th we make quite bad sales, right? So we are falling from there. And same time the another fall you can see over here is 5 till maybe 7, 6, 7 or 8, something like that, right? So guys, that was actually like the not a forecasting, right? It's like a sales plotting, because we're not making any simple moving averages strategy over here or something, like the moving averages to check like what is our trend right now, right? So we're not looking after that. We're just plotting the simple units sold by days, right? So let's move on into another one. We can take like how much is look as per monthly sales, right? So I'm not gonna go for the weekly sale. I'm just gonna go to monthly sale. So for that, I can do simple thing, right? I'm gonna copy this again. For some of this, I'm not gonna use all of them, right? I'm just gonna get rid of this, and I'm gonna write a fresh code on the top. Let's say month unit uh, units, right? Sum equal to df dot group by, then we have month, and we have units dot sum dot reset index. So it will reset whole the index. Okay, let's say month unit sum. So next what we're gonna do is like we're gonna convert the data types into a string, right? So let's say month units sum, month, right? Equal to month unit sum, month as type, string. So month unit sum, I'm just gonna copy this and I'm gonna just replace this with pressing control and putting a cursor which word I want to replace, and I'm just gonna delete this. If you're using Windows, then control V, right? So unit of sold per day, unit of sold per month. Instead of days I will take month, right? So unit sold, let press shift and enter. Okay, something is wrong over here. Okay, day, I forgot to replace this one. Instead of day, it's need to be month now. So these are the thing you need to be very careful when you are scripting, because you remember we are using a month, not days. So now you can see over here, those are the monthly trend. So by checking monthly, we're actually in a good shape. So our daily sale is not quite well, but our monthly sale shows we are still making profit, right? So guys, that was fun. So let's move into our another plot that is known as a bar plot. Well guys, if you type bar plot in Google, so this will give you a different kind of plot. Some are really beautiful, they have different colors, but we're gonna stick with the simple plot like this, the blue one, right? So I just want to use default one right now. So in future, I will show you like how to make a colorful one, just to make you understand. I'm gonna make a simple plot, and I'm of course gonna save some time, right? So let's move on. So I'm gonna make a new heading over here. Let's say line plot, right? I will say 4.2 bar plot. Oops, sorry, bar plot, right? So okay, so what are the thing we can plot in bar? Okay, first thing first, transaction type. So these are the card and the cash. I want to know how many unit or how many time people has made from card payment and people are made from cash payment. So there is a one thing I have learned, right, in a business analysis, that people spend more money with card when they go to mall as compared to cash. So when they carry card, they spend more money because they get more options, right? And of course it was loaded, right? Let's say you have a credit card, you'll spend more, you'll take more credit. If you have a debit card, you'll spend more from whatever debit you have into your account. And same when you have a cash, a limited amount of cash, you will think twice to spend those money because you have a limited amount of cash, right? Let's say you haven't carry any card in the shopping mall, right? So that is how the marketing and branding work, right? So people spend more by card, right? So anyway, I'm not promoting over here, or I'm not like doing any promotion, so there's no censor in this video. I'm just showing you what is reality, right, with the help of the data, right? So I'll do just a simple thing. I will say transaction type. I'm just gonna iterate through those columns, and I'm gonna say dot unique, not unique, sorry, I will say dot values count, open and close parentheses. Oops, sorry, value, oops, I made some mistake here. Values counts, yep, there we go. So it's a value counts, not values count, right? It's a value count. Then let's say uh we have card that is 2811, that is 2811 customer, where cash is nearly uh 12, sorry, 1289. So if I really want to make some calculations, right? Oops, sorry, division symbol, right? I'm just gonna go over there into 100%. Oh, okay. So card divided by cash, right? And I have to minus this first, right? Just putting a simple formula, right? So card minus cash and divided by the cash customer, right? So look like 118%, right? So 118% people spend more with the card as compared to cash, right? So that is one of the analogy of our data set, right? So in the data set we have received the people have spent more into the card payment as compared to cash payment, because it is 118% more people have spent with the card, right? Okay, that's cool, but how can we plot this? So I'm just gonna do simple dot plot into the same block of the code which I have wrote on the top. I'm gonna press shift enter, so that will give me a line plot. But if I say kind inside the those plot, and sorry, in the quote I will say bar, so it will give me a bar plot, right? So I'm just gonna use a grid line over here just to make it nice, right? So in x-axis we have transaction type. We just need to put plt dot y label, that will be number of payments, sorry, total number of payments, right? Total number of payments, right? And I'm gonna say plt dot title, uh card versus cash payment, right? So this the comparison between the card and the cash payment. And I will say plt dot show open and close parentheses, so this will remove this unnecessary text over here, right? So now you can see over here that's how the plot look like, and that is our analogy, and this is our in a percentage, so we can say something like that f string, right? We can put this into the open and close parentheses over, sorry, open and close curly braces. Let's say uh card payment customer are more than cash payment customer, right? So card payment customer are uh if I can use the percentage symbol over here, and if I can just also put like dot sorry, column dot to f, that will round off two time. So yep, that's a round off two time. So card payment customer are 118.08% more than cash payment customer, right? So that's the f string, right? Inside the f string I have declared those string which I have to mention uh, in our print options, sorry, print screen, right? And that's your parentheses over here, sorry, column over here, close column. You have a open column, right, inside the f string, and you define the curly braces where you put the formula, right? The formula is simple. Your transaction type index 0 that define your card payment, right, minus with the transaction type with the count index 1, that's your cash payment, right? If you want to see, I will show you, right, just to make it more clear and bring more clarity. So now you can see over here that's a 2 8 11, that's we are indexing through this value with the 0, and another indexing through this value is the 1, right? So we have taken basically card minus cash divided by cash into 100%. So you can see over here this will round off into 2 decimal point, right? So that's cool. That's a really simple example, right? But now I want to know a very important thing, right? I want to know about my total amount per month, how much I am receiving total amount per month, right? I'm not interested on day, right? I'm only interested on month right now. Then I will look through the week, how much we are making per week, right? So we're gonna do same like we have did above over here, but we're gonna make into a bar plot. We'll say month, right? Month sums, right, equal to df dot group by, right, I will take month, right, and I'm going to say something like amount dot sum, open and close parentheses, dot reset. So this will reset the index again, right? Because we're gonna look to the first one, second month. We're not gonna look into the mixture of various months, right? So I will do same again, month sums, right? So month, uh Okay, so equal to, so let's say month sums, right? And I'm gonna iterate through the months again. So gonna convert it into data type into string. Okay, I'm just gonna run this. Now I'm gonna open the month sum. Now you can see over here we have month and the amount. We have accumulated all the value into a single value with according to the month, right? So what next I can do is like PLTBAR, right? So month sums, right? Month sums, then I will say month, right? And I will say month sums, right? And I will define amount. Uh, so I'm gonna label it, right? So I'm gonna label it, gonna make a descent, total amount, right? So this will give me a bar plot. So to save time, I'm just gonna copy this again from the top, and I'm gonna do scripting over here, right? So the scripting will be total amounts, right? I will say on the title it will be uh monthly amount, according to unit sold. We can say something like that. You can write it on your own language, right? It will be more genuine if you write into your own language. X label, I will say month, right? So don't worry about the mistake. You can change the mistake if anything happened, because we are writing in Python. So Python is like more you can customize, so don't worry about that. So now you can see over here total amount we have made on the month 12th is quite higher, and it is like the double the amount we made per every month. So in first month, 7 month, 8 month, if you double it up, right, you won't be able to receive that much amount we made in 12th month. So 12th month was a really good sales, right? So guys, let's try with the week. So for the week, you can do simple. I'm just gonna copy this again, right? I know I'm doing this quite a lot just to save time, right? But I will make you understand while I'm writing this code, right? Instead of month, I will say week, right? I will say uh, something like week, or let's say like weekly sales. Sorry, I'm just gonna re-edit again. I want to be more specific, right? So weekly sums, and it's going to be month amount. So instead of month we will take a week. So same with month, I'll get rate with this, I will say week. So now we can see, let me show you on data frame, right? So we are actually going through this one, the second column, right? Week. So I'm going to run this, right? So I'm going to copy this again. So before copying this, I will show you again weekly sums. Now you can see over here, those are the week one. That's the amount of money we made, but it can depend like there's a 53 weeks, right? So but it depend on the overall sum of value. So instead of month, I will write over here this weekly sum, right? So I'm just gonna get rid of this weekly sum, right? Instead of month, I will write week, month, I will write week, month, I will write week, weekly amount according to units sold. Okay, so that's how it's look like, weekly amount according to units sold. But you can see there's overlapping between the number. Uh, we can solve this though. We can solve this quite easy, right? So we'll say plt dot let's say fig size, right? Figure, and we'll say equal to, we'll have open and close parentheses. I will say 10 by 6 maybe. That's look fine. Oops, sorry, something is wrong. Fig size. Matplotlib has no attribute fig size. Plt dot. Oops, sorry, I made some mistake over here, right? So I will check in a Google and again plt dot fig size. So plt dot figure fig size. So I have wrote the opposite way around, right? I'm just gonna copy this, right? I'm just gonna paste this over here, right? So there we go. Oh my god, that's quite big. So I don't want this much big because I have to make some changes. I made a copy paste from the Google. Because of that, there is a little bit irregularities into my plot, but now we have regularized those. Now it has gave us a decent plot, right? So I can do one more thing, right? I can just uh I'm like I can just make the axis, right? So let's say axis into some angle, let's say dot plt dot x label, and I will change into a rotations, right? Oops, sorry, not label, ticks, because see those numbers over here, we call them ticks, right? So ticks, and it will be rotation equal to 45, right? So that's the 45-degree angle. That's how it's look like our chart, weekly amount according to units sold. So the analogy over here, right? The analogy over here is the 51 week we had made the highest sale, and the second highest sale was a 52 week, right? The least amount of sale we made is 53, right? So that is the quick analogy about our sales, right? So the algorithm today we are using is random forest classifier, right? So random forest classifier is a, let's say, a machine learning method used for classification task, right, that combine multiple decision tree, right, to improve the accuracy and the robustness of prediction, right? So here is a simple chart over here. You can see over here, right? So you have a X data set, you have N1 features, N2 features, N3 features, and N4 features, right? So this feature will be basically, let me see, df, right? So the columns, the number of columns we are selecting over here, right, those are our features, right? So we're not gonna select all the features, right? We're just gonna select the important features which are basically needed for making those classification tasks, right? So let's say the random forest started by creating a multiple subset of the training data. You can see the multiple subset of the training data, right? So this is done using a method called bootstrapping, where sample are drawn down randomly with replacing this means sum sample by appearing multiple time in a subset, while other may not appear at all, right? So you can see over here, even like we have just this photo is not clear. Maybe you can see over here tree 1, tree 2, we have tree 600, and we have prediction 1, prediction 2, and prediction 600, average of all prediction and random forest predictions, right? So so let's say building decision tree, right? So you can see the tree structure over here, right? So those are like the probability, right? So these are basically your tree structure, right? So for each bootstrap sample, a decision tree is built. However, unlike standard decision tree, not all features are considered when splitting node in a tree, right? Instead, let's say a random subset of features is selected as its split. This actually introduced the diversity among the tree, right? So the algorithm select the best features from the bootstrap random subset to split the data at the each node based on a criterion like Gini impurity or let's say entropy. So let me show you the Gini impurity and entropy. Okay, so that's the one, Gini impurity, right? So classification, you can say F. Let me open this in a big image. Yeah, you can say Fi is the frequency of a label I at a node, that's the data point, right? So and C is the number of the unique labels, right? So similarly over here, entropy is in a form of log. You can say minus Fi log Fi, right? So Fi is the frequency of label I at a node, right? And C is the number of unique labels, right? So after this, the voting is done, right? I've shown you in this chart, the previous chart. Sorry, I haven't made any model for this video, to be honest. So over here, there's average prediction. There was a one photo or one image I have seen in the Google. Yeah, there we go, right? So it's not clear, but you can see there majority, voting, and final class, right? So once all the tree are built, each tree make a prediction for a given input, right? So each of the tree, so the final prediction of the random forest classifier is determined by the majority among voting all the trees. So there will be a voting going inside the panel, right? That's quite funny, but it's actually true, right? So the class that received the most vote become the overall prediction, right? So that's basically become the overall prediction, right? So out of bagging error estimation that we are using for the validations, uh, if I can show you somewhere over here, right? So let's say since all samples are used to train each tree, the unused sample known as the out of bag samples can be used to estimate the model performance. This provides an internal validations method without needing a separate validation data set. So once we're going to write the code over here, so I will show you how this all step will make a common, like a perfect sense, right? A perfect common sense over here, right? So we're gonna use this right now over here, right, in our Jupyter notebook, in our another block. So I'm gonna import all the random forest, right, libraries. Same time, so what is the advantage of the random forest library? So random forest reduce overfitting compared to a single decision tree due to the average of multiple trees, right? And what are the feature importance, right, is provide the insight into the importance of different features in making predictions. So what we're gonna do right now, we're just gonna import library. Let's say import scikit-learn, right? So scikit-learn dot model selection, right? And I'm gonna say import let's say train, test, and split. So I'm going to import train, test, and split, right? And another I'm going to import is random forest classifier. For that I will say from scikit-learn, right, dot ensemble, right, import random forest classifier, random forest. I don't know why it's not coming up. There we go. Just press enter. I will say from I'm just gonna import this, and I'm gonna import a metric later on, right? So okay, first thing first, uh what I'm planning to do over here, I want to check the card and the cash payment customer, right? I'm gonna convert them into binary digit. I'm gonna convert card into a 0, right, cash into 1 in this column. First thing first, right? So I'm gonna convert that into 0 and 1, which is our features, sorry, which is our target, not features, right? Target is basically your y-axis, and features is your x-axis. So feature is like your independent variable, and target is your dependent variable, right? So let's say df, oops, sorry, let's say df, I'm just labeling the target, right? Let's say df transaction type equal to df transaction type, oops, sorry, some mistake again, right, dot replace. So I'm gonna use open and close parentheses and curly braces. Inside the open and close parentheses, I'm gonna mention card. So need to watch the spelling, C-A-R-D, C need to be capital, right? Put inside the code, that's gonna be 0, and same like cash, right? And it will be 1. So there's a dictionary inside this, right? So we have the key and value, same like we are labeling that. Oops, sorry, something is wrong. That's a spelling mistake again. Replace, and I'm gonna check my data frame again. Now you can see over here our card has been converted into 0, and our cash has converted into 1, right? So are we sure that it's happened everywhere? It's just first top 5 columns. So for that, df, just to validate this hypothesis, transaction type dot unique, open and close parentheses. Yeah, you can see now 0 and 1, or you can just do like simple value counts, open and close parentheses. So there we go, we got same value with the card and the cash, which we have got above, right? So if you remember over here, right, that's the same one over here, right? So okay, next, and moving forward, I will say features, right? So features will be my x equal to df. I'm gonna put uh the round, sorry, not round, square bracket, my square bracket twice, right? I'm gonna use the units, then I'm gonna use amount. Right, guys, I'm just trying to do some multitasking over here, coding, talking, and of course, like trying to solve this technically. Sorry if I'm making a lot of mistake over here. I'm just trying to be in a one go. It's not quite working out well, but let's keep trying. So let's try this. X is features, Y is transaction, right? Transaction type. I'm just gonna press shift enter. Okay, so now what we have did over here is we have did a step called feature selection. So this is a step in machine learning which is known as feature selection, right? So after that I will do feature engineering, or we can say, actually this is a whole process of feature engineering, right? We can say feature scaling, feature scaling. So I'm gonna convert mean to 0 and standard deviations to 1. So that will be x equal to x minus x dot mean, open and close parentheses, divided by x dot std, right? So I'm just gonna check few of the 5 columns. Now you can see over here my x has been feature scaled. So let me show you the formula. Feature scaling formula. So these are the feature scaling formula over here. So standardization, right, and normalization. So standardization, we are using this formula, which x minus x mean divided by standard deviations of the x, which is basically your features, right? And normalization, we use the x minus minimum and max minus minimum, right? So we are just using this one because on this one we are converting 0 as a mean and 1 as a standard deviations, right? So if you say feature scaling mean, right? So oh, this is something on the block of this. What is feature scaling? Feature scaling is a method used to normalize the range of independent variables, which is basically features, right? In data processing, it is also known as data normalization, generally performed during the data processing step to make training faster. It helps you to train faster. You train your data, right, while using a machine learning or deep learning algorithm. In deep learning, without feature scaling, you cannot train the data. This prevent you from getting stuck in the local optima, which is basically your gradient descendant. It gives you better errors surface shape, right? Of course the curve, right, the curve you see in the weight and the bias, right? So weight decay and base optimization can be done more conveniently, right? So weight decay and base optimization is basically about the neural nets, right? So just the equation of line, you know what I mean? So yeah, anyway, right, so let's move on, guys. Let's moving forward. So I have selected my features, which is our independent variable, and y is our target, which is our dependent variables, right? I have feature scale them, right? After feature scaling them, I have shown you the formula. And what I'm gonna do is I'm gonna split those data into a train and test, right? So let's say split data into train. Oops, sorry, I don't want to make a capital, into train and test. So let's say x train, right? X train, I'll say x test, I'll say y train, I'll say y test, right, equal to train test split, right? I'm gonna say x and y, right, and say test size. Test size will be something like 20%, right? And I'm gonna do random state to 0. I don't want any random state right now. Well, random stage also good when you are actually using a test and train, because it's provide more random movement over there, like randomization, which can use for testing. So I'll just put into a standard where everybody kept it like 42, right? I'll take a 42. I will say now classifier RF, that will stand for random forest. Let's say classifier, right? So let's make a comment over here. So 80% of data will be trained and 20% will be used for test. Okay, that's enough. So I will say over here, creating model. I'm just gonna create a model over here. Random forest classifier. I will say random forest classifier and an estimator. An estimator, I will take 100. 100 will be fine, right? And I will say random state. I will take again 42, right? Gonna RF classifier. Now you can see over here, we have random forest classifier with the n estimator 100 and random state 42, right? So what I'm gonna do is I'm gonna fit the model. So I will say RF. Let's say classifier, right? So if I press a tab, oops, sorry, C capital. If I press a tab and I will say dot fit, it's gonna fit the model X train, right, and Y train. So we're gonna use a train set. So now we have trained our data. So I will say fitting model. Right now we have to make a prediction. So Y predict, right? So Y predict equal to RF classifier dot predict. So we have to make a prediction on X test set, right? So we are only using a test set for prediction. So Y predict, I want to take 10 of those columns, let's say, or 10 of those data points. Right now we are not in a data frame, so it should give me the 10 of those data points. So those are our predictions. So we know the predictions, but the funny thing over here is we can't see anything instead of binary 0 and 1. So how we gonna know if the prediction is correct? So first that we gonna evaluate the model, right? So moving forward, let's do model evaluation. So before that, I'm gonna show you what is model evaluations with the formula. Right guys, so now we are walking through the model evaluations, right? So the model evaluations will define how perfect our model is and how accurate it is. So I'm just going to walk you through the truth table first. In the truth table, we have positive, we have negative prediction class, and we have actual class, which is positive and negative. So true positive will be like correctly predicted cash payment, and true negative will be like correctly predicted card payment, right? So similarly, if you see the false positive, it says predicted cash payment, that we actually use card payment. So that's actually the type 1 error. When it's come to the false negative, which is type 2 error, it will say like predictive card payment, that were actually the cash payment. So this is actually the cash payment, but it's defined as a card payment. So this will be actually the uh, as a cash payment, but it is a card payment, right? So guys, first thing I'm gonna do is I'm gonna import my library over here, right? I will say from scikit-learn dot matrix scikit-learn, oops, sorry, learn dot matrix import. I'm gonna import accuracy score confusion matrix, right? So I'm gonna declare a variable over here, confusion matrix, right? So the confusion matrix will be a variable which will basically store the confusing matrix function, which will be like confusion matrix, and I will use like a y test data, and of course the y predict y predict. So after that, I'm gonna make like true, let's say true positive equal to let's say confusion matrix. Oh, sorry. You know what I'm gonna do is I'm just gonna take this confusion matrix right now. We need to know which one is true positive, which is true negative, which is false positive, which is false negative, right? So for that, true positive equal to, let's say, confusion matrix, right? And where and second row and second column should be one by one, right? And let's say true negative, right? I'm just gonna keep this into small. Cannot keep that into the capital because we have to follow the snake case as a Python coding rule. So there is a protocol we have to follow. Let's say true negative equal to confusion matrix. I'm gonna say 0 by 0, right? And I'm gonna say false positive, which will be confusion. Oh, sorry, confusion matrix is gonna be first row and second column 0 by 1. And let's try false negative. This will be confusion matrix. So second row and first column, and we can use a simple print function, right? Print, let's say f string. I'm just gonna copy this at least four time, right? And I'm gonna just write over here something like true positive, and it will be true positive. Another will be let's say true negative, true negative. Let's say false positive, false positive, false negative, say false negative, right? I'm just gonna run this. Oops, sorry, I forgot to use a space and a column over here. So that will make this pretty. So yeah, so true positive. Basically, I have told you on the earlier that when we're using a truth table, we are defining like what are our predictions. So our machine learning model saying true positive, which is correctly predicted as a cash payment, is 157, and true negative, which our machine learning model saying like it's actually a card payment, that is 487, and same time which is false positive is predicted cash payment, that but it is actually a card payment, right? When it's come to a false negative, those are predicted as a card payment but those are actually a cash payment, right? So that's quite easy, right? It's really simple. But now you can see over here we are moving forward. Then we have sensitivity, we have specificity, right? So then we have accuracy, negative prediction value, and precision, right? So we don't need to go through that of all, right? So first thing I would like to do uh, is just to show you um how we can how we can use a heat map, right? Heat map to make a confusion metric plot, right? So for that we're gonna use a seaborn, right? SNS dot heat map, SNS dot heat map. Let's say confusion matrix, right? I'll annotate, so that will give us a text over there on the chart. FMT, CMap, uh, blues. Oh, sorry, forgot to write equal to sign over symbol over here. Then I will say X tick label. It should be negative, and positive. Y tick labels. It will be negative and positive. Right, so let's try. So 487, that is our negative negative, perfect, and positive positive is 157, it's true positive. And let's say negative positive is 79, 79, that's fine, false positive, right? Because it's positive section and it's false, right? Similarly, like negative positive negative, that's 97, right? 97, okay. So let me check the spelling again. Negative, positive, positive. Spelling look fine, right? So that's not an issue. I will say plt dot title, right? I will say confusion matrix, plt dot x label, predicted, predicted, plt dot y label. This will be true, plt dot show. And if you can change the size of this plt dot figure, right? Fixed size. So I don't want to make a mistake again, like last time. So figure need to be outside and fixed size need to be inside the parentheses. So 5 by 5, or maybe I can say 5 by 4. 5 by 4 is fine, that's decent. So predicted true. So now you can see it's look like this, right? Right, so that's cool. So now we are moving into accuracy, precision, recall, right? So those are the formula. If I can show you the formula first, because I'm not going to use a formula, I'm just going to use a direct model, right? So directly I'm going to import the model and I'm going to just use them to calculate those. So accuracy is true positive plus true negative, which is basically our true positive, true negative, divided by true positive plus true negative plus false positive plus false negative. That's called accuracy, right? So for accuracy, uh, for calculating accuracy, what I can do over here is I will just say accuracy. Accuracy, you know what, I'm gonna do directly, right? So I'm gonna use explicit way, right? So I'm gonna define a print function, right? I'm gonna use a quote and I'm gonna use curly braces, right? I'm just gonna zoom this in. I'm gonna say accuracy of model is, right, accuracy score. Then I'm gonna say y test, right, and y predict. Okay, something is wrong. There we go. There need to be a parentheses. There we go. And pardon me. So dot 2f. So that will round off into 2 time into 100, right? Oops, sorry. Don't need to do that. Yeah, 0.79. I'll take like 4 times. So 0.7854. That's like 78.54%, right? That's the accuracy of our model, right? So another is precision, true positive divided by true positive plus false positive, right? So first thing I would like to know, like sorry, I would like to tell you that why are we using this, right? So what is the reason we are using accuracy? So accuracy can be basically the accuracy is always in a ratio, but you can also use in a percentage cases, right? But accuracy give a general idea to tell how well the model perform overall. However, it can be misleading if the data set is imbalanced, right? If one class is much larger than other class. So after that, let's move on to this one, right? So precision, right? So the first thing is like, what is the precision, right? So the precision is it's useful when the cost of false positive is higher, right? For instance, if you misclassify a card payment as cash, it could lead to incorrect processing, right? So that's how we check the precision, like how precise, right? How precise it is. So I'm gonna use same thing. Oh, sorry, I need to import over here. I have imported the imported our accuracy, but we also need to import our precision score. So I'm just gonna copy this, right? I don't want to touch this block. So import let's say precision score, right? And we call recall score. Then we'll go to F1 score, right? Then we can go to overall classification report, right? So I'm gonna use the same method. I'm just gonna copy this, paste over here, and that's look fine. I'm just gonna do some editing over here. So instead of accuracy, I will say precision, right? And of course over here I will say precision score. I'm gonna run this now. The precision is 0.6653. It is 66%. It is not really well. That's quite not well, right? uh what we can do next is we can go to the recall. So what is the recall, right? So the recall is like so important when the cost of false negative is high. For instance, missing a cash payment, let's say prediction it is as a card payment, can lead to revenue loss. So recall is the ratio, right? It's a ratio form, and we can also convert it into percentage, the way you find is more comfortable. So it's measure how many actual cash payment were correctly identified, right? So you can say recall can identify in our data set right now how much actually cash payment has been identified. But in a precision, it's measure like how many of the prediction cash payment are actually as a cash payment. So precision was also like the how much precise, and same the recall is like how actual cash payment were correctly identified, right? So I'm just gonna call the recall function over here. I'm gonna say recall over here, right? So let's say recall score, right? So the recall score is like a 0.6181. That's like 61%, right? So that's not really well, but still all right. Sum up the 51%. um well the score is like 78, right? 78%. Of course this thing will go down, and if you have a very good score, precision recall also go really well most of the time, right? So now we're gonna move into the F1 score. You know what, to make this more nice and good looking, let's say pretty, right? So I'm gonna make it uh mark down over here accuracy, right? After accuracy I will say I'm sorry, we'll say precision, right? And I'm gonna say recall. So I haven't did any hyperparameter tuning over here. I'm just normally using this to, if you want to improve the score, you can do the hyperparameter tuning. So the hyperparameter tuning need to be done from feature engineering to everything, all the step by step. I'm just showing you how to use the classification model to make some predictions, right? So in another video in future I will show you how to use a hyperparameter tuning, uh, or maybe like I'll make another video on the same data set with a different model to use a hyperparameter tuning to improve the score. But sometimes the data set is not really well, uh, you cannot improve the score. So it's also depend on data set, right? So there's a lot of parameters we have to look after. So next we are moving into F1 score. Yeah, F1 score. So I'm just going to copy the same thing again. I'm going to write over here F1 score. So when to use the F1 score, right? So the F1 score is a good measure when you need to find an optimal balance between the precision and the recall. So the if you have to find the optimum balance between precision and the recall, right? Especially in the situation where you have an imbalanced data set, right? So if you have an imbalanced data set, then you will consider the F1 score. So the F1 score is the harmonic mean of a precision and recall. Let's say the harmonic means, right? And it's balance between metric and is useful when you need a balance between precision and recall, right? So let's try this. This one will be F1 score, and let's say F1 score. Hopefully my spelling is correct. F1 score, If I can run this, the F1 score is nearly 0.6408. Right, guys, so moving on, next is ROC curve. So ROC stand for receiver operating characteristic, right? So your y-axis will be true positive rate and your x-axis will be false negative rate, right? So this curve will define your ROC curve where true positive rate versus false negative rate at another threshold, and this is true positive rate versus false negative rate at one threshold. So there's a 1 over here, there's 0 over here, there will be 1 over here, and this is above the 1, that's why at another threshold, right? So let me show you. That's the truth table, right? So yeah, that's the one, and yeah, that's the one. You can see over here true positive rate, false positive rate, so 0 to 1 and 0 to 1, right? And same time we are gonna make this kind of curve on the ROC curve. So this is your the line, right? This is a diagonal line which is also known as non-discriminations, right? So the diagonal line which is a non-discrimination line, so in this line, the above if the curve is above this line, it will be better. If the curve will below this line, it will be worse, right? So the perfect will be on this point, right, where true positive rate, and you can see the false positive rate over here. So we're looking for true positive rate over here. This will be a perfect classifier, right? And let me give you a little bit overview with the definitions, right? So the best positive predictions method would yield at the point in the upper corner of the upper corner or coordinate 0 1 of the ROC space, representing 100% sensitivity, no false negative, right? So we're looking for this area where's no false negative, right? So 100% sensitivity and no false positive, which will have 100% sensitivity and no false negative. So you can realize over here is saying no false negative, right, and it's saying no false positive. So if you remember, in our truth table we have false positive and false negative. Those are our wrong predictions, right? So what we are trying to do over here, we are trying to put a curve on this area which will say representing 100% no false negative and 100% specificity, which means no false positive. Then 0 1 point is called perfect classifications. So this is the perfect classifications, or a random guess would give a point along a diagonal line, that's so called line of no discriminations, right? So this is the line of no discriminations, which basically is segregating the two side of the area under this whole area, right? Whole plot. So from the bottom left to the top right corner, regardlessly regardless regardless of the positive and negative base rate. An intuitive example of random guessing is a decision by flipping coin. So let's take an example of flipping coin. As the size of the sample increases, as more we flip the coin, right, a random classifier ROC point tend toward a diagonal line, right? In the case of balanced coin, it will tend at the point 0.5 0.5. So it's saying like more we increase the sample size, right, so more we flipping the coin, as the size of a sample increases, a random classifier ROC tend toward a diagonal line, it will tend toward a diagonal line, right, this diagonal line. And if the case of the balanced coin, if the coin is balanced, let's say the coin is balanced, we have same amount of head and tails, it will tend to the point 0.5 and 0.5 over here, right? So guys, let's move into the coding session. Right, so first I'm gonna import ROC curve and AUC from same sklearn matrix, right? So first thing first, I'm gonna make a y test score, right? Oops, sorry, y test scores, right? And it will say RF classifier dot predict. We're gonna predict into the form of probabilities, right? And I'm gonna say x test gonna be in a closed parentheses. Then we're gonna select the class 1, right? And after that I'll show you how it's look like. So we're just selecting the class 1. So these are the all classes 1. So you can see over here, I'm just gonna put this into the at least 5 of them. I don't wanna waste time, right? So let's say false positive rate FPR, then we'll say test, then we have true positive rate test, right? Then we have threshold, THRESHOLD as threshold test. Pardon me, threshold test, and we'll say ROC curve. Well, that's really Y test and Y test score. Excuse me. Right. So ROC AUC test, and I will use a function AUC that will be FPR false positive test. Then it will be true positive, true positive rate test, right? So if I can see this ROC AUC, oops, sorry, ROC AUC test says 0.88, right? So I'm gonna plot this now. PLT dot figure, right? I will say fixed size, and gonna put something like 6 to 5, a small one, a small decent one. I will say PLT dot plot, and I'll go for FPR false positive rate test and true positive rate test. So if you remember on this curve, true positive Y and false positive X, so X is our false positive test and true positive is our Y. And I will say color equal to, I will say blue, I would like blue, and label something as let's say ROC curve, right? And it's actually a test. No, I don't need to do that, so I can just plot this. Okay, that's how it's look like, right? So I need to add some those lines from the middle, the dash lines from here to here, right? So I'm gonna create that with the, I would say plt dot plot. So I'm gonna define 0 to 1 first, x, right? Then I'm gonna define the y, 0 to 1, right? Sorry. Then I will take color equal to red. Then I will say line style dash dash, right? So now you can see over here, that's how it's look like. But I want grid line. I'm just gonna, for the grid line, I'm gonna go on the top, gonna copy this grid line. Just gonna do some scripting to save some time over here. Now you can see those are our grid line. And now I need to give a title. Let's say plt dot title. Title will be something ROC, right? ROC curve, and plt dot x label, that will be false positive rate. Oh god. False positive rate. Then plt dot y label, true positive rate. Plt dot show, right? We have false positive, and we have true positive rate, right? Then what we can do over here is we can also add legend. So I will say plt dot legend, legend, loc, you can say lower, maybe lower right, somewhere in the lower right. Yeah, okay, that's look really cool. But I want to know also the value over here. So what I can do over here is I can just add something like f string, not f string, right? I can just like area All right, at curly braces over here, dot, sorry, column, then dot to f. It will give me 2 point decimal, then format. So I'm using the other way around, right? So ROC AUC test, ROC AUC test. Oops, sorry, I forgot to put some comma somewhere. Um, LABEL label, then the ROC curve. Oops, sorry, I forgot to put a dot over here. So now you can see over here, this is so 0.88, and of course I have to use a close parentheses, so that will give me exactly like this, right? So now you can see this is how our ROC curve look like, right? So let's move on to another one. The final one is a decision boundary, right? So I'll call it decision boundary. So we have understand the truth table, we have understand the ROC curve. Now the decision boundary is also to visualize how those prediction look like, because hopefully you remember over here where I talk about the prediction, right? This one earlier, right? How we gonna plot this? How we gonna know like how it's look like exactly, because over here we only have a binary digit, right? So we have used confusion matrix, right, to know which are the true positive, true negative, which are using a card payment or cash payment, right, which are falsely predicted as are using a card payment or cash payment, right? So but we have ROC curve, but we still cannot visualize properly. So for the visualization, a proper visualization, we're going to use a decision boundary. So decision boundary will be very tricky, but you will have a rough idea how classifications model work, right? So next step is our decision boundary. Right, guys, so let me show you how decision boundary look like. So in the decision boundary, you have this kind of plot. That's a random forest, that's a logistic regression, that's KNN, uh, and that's a decision tree. So this is not quite well defined, because the x and y axis is not labeled properly, right? If I can show you some of the example, yeah, see, that's the one. You can see over here employment, durations, and the income. You have a default and the repay, right? So if you can create a line on this area like this, right? If you can imagine my cursor, just imagine a black line, right? Passing through this scatter plot, and just imagine like when I'm moving the cursor, there's a line drawn like this. So this is your decision boundary, right? So between the income and the employment, where the default and the repay, right? So is there any more example I can show you? Because I want to show some real database, right? Not theoretical one, right? I want to show the real data which we can use in a real life. No, so definitely we can plot this, and I can show you, but this is how this look like. But that's a class 1 and class 0, but there's still a wrong. See that how they have mentioned over here, class 1, one of them need to be 0. Let's take example, green one is 0 class, right, and red one is class 1. So that's the line separating them is the decision boundary, right? Same over here, decision boundary, so which will define like uh, where is the thin line between those two variables, right? So we're gonna plot this. So let's start with the coding session. Right, guys, first thing first, right? So first we need to know the features. So if I'm gonna open my features, now we have unit and amount. So we are using the unit and amount in our decision boundary, right? And secondly, the target, we know the target is basically our card payment, right? So we still remember that. So we're gonna create a mesh grid, right? So first we're gonna create a mesh grid. So mesh grid will be x minimum and y sorry, x minimum and x max, right? So we're not looking after the y right now. First we're gonna create the x, right? So uh let me open this again. uh okay, Let's me take this one, right? Just a simple one. So we are looking through this X area, right? So that's why we created the X grid, right? So X, we are looking for unit, because this columns, we are looking after this columns, right? And we're gonna look for dot minimum one, right? So after minimum, we're gonna uh, use X units again. So this time we're gonna look for the maximum one, right? So this one will be plus one, so the previous one is minus one. After this, we're gonna just copy this again, gonna paste this again. So instead of X, I'm gonna use Y, right? And same time over here, I'm gonna use a X. I'm not gonna change anything over here. Instead of that units, I'm gonna use a amount over here. So amount, so the Y will be amount, X will be our unit. So we are using the same feature as a X and Y, and the binary digit will be here, right? So let's imagine like the blue one is your 1, and let's say the orange one is your 0. So similarly, we have the features here and here. There's a unit and amount, and those binary digit will be here, and our machine learning model will predict those line which will separate them, right? uh, excuse me. So now we have xx and we have yy, right? So now we're looking for np dot mesh grid, uh mesh grid grid. So np dot arrange, if you know, the arrange function is used to create basically it's like a it's like a for loop, right? In for loop, you use to create from numerical value, like I say, x for x in range from 1 to 11, it will give you from print from like from 1 to 11. Let's say like x for x in range, right? So we have 1 to 10, and we have a interval of 2, something like this, right? So similarly, if we have an interval of 0 0.2, oh sorry, it doesn't support the floating, oh just the one, then we have the interval of 1. Similarly, we are using the same let's say like we are using the same concept over here, x minimum, then we have x maximum, then we have 0 0.1 as an interval, right? Then we have np dot arrange, oops sorry, arrange, I'm double checking the spelling over here, I don't want to make any mistake, y minimum, then y max, 0 0.1, same thing. So now we have to predict the grid, right? Predict on the grid. So I will say z for that, z equal to rf classifier dot predict. We're gonna use the same our model to predict those lines. So np dot c, right, and xx dot ravel, open and close parentheses, then yy dot ravel, open and close parentheses, and then I'm going to use the close parentheses again, and z equal to z dot reshape, so xx dot shape. So if you remember, these are basically used for the dimension, right? And I'm going to use plt dot figure, it's like 2D and 3D dimension, right? Fixed size, uh then we're gonna select 12 to 8, and I'm gonna say plt dot contour plot. We're gonna use a contour plot, contour f, right? We're gonna use xx and yy, and of course z, right? We're gonna use x, y, and z. I have used a small z, and I'm gonna use alpha, alpha something around 0 0.5 maybe, or maybe I can give 0 0.4, and let's say cmap equal to plt dot cm dot rdy1bu, right? So that's the basically the code. You can use a Google to get more different kind of codes. So for contour cmap plot, different code, right? So that's basically give me like yellow to blue. What you can do is like just copy this, and you can just cmap, right? Oops sorry, go in matplotlib there, is a lot of documentation you can read and you can just find over there, right? Let's not waste our time. Scatter, right? So I will say x units and x amount, let's say c equal to y. Then I will put a edge colors, right, k, and scatter equal to something around, I'll keep a small, I want to keep a little bit small, something like 20, uh something like 20. Yeah, I'm gonna use a same c map again, because I want to identical. I don't want my binary to be different. Binary, I mean like 0 and 1 to be in a different, and same time I'm using contour the same way how I want to present the binary. So when we'll plot, I will explain you the each line of the code, right? So plt dot x label, this will be units, let's say units, right? And I'll say plt dot y label, so it will be amount, right? And I will say plt dot title, which will be random forest decision boundary, right? So plt dot color bar, and I will take like text equal to 0 1, label equal to transaction type, right? plt dot show, right? So I'm gonna double check all the code again. Let's look fine, and this look fine. Classifier for prediction, and okay, let's run. What I'm gonna do is I'm just gonna print this, all of those plt color maps, right? So plt color maps, open and close parentheses. Okay, so you know what, we can use other one, right? We don't need to stick with that. So I'm gonna use something as maybe magma. Let's try magma. If I can just maybe like replace this with the magma, should be fine. Okay, let's run. So okay, so that's how this look like. Okay, that's look fine, but I really want to make it more cool. Let's try with this one. Something like cool warm r. Oh, cool warm r. I should have created a function, but it's alright. Okay, yeah, that's what I'm looking for. So yeah, now you can see over here. So we have the feature scaling over here. If we don't do the feature scaling, right, so it will give you the amount, the value of the amount, and it will give you the units. Units is basically the amount of the units we have sold, especially any kind of product or service, especially the product we have sold, right? And you can see this one, the red one and the blue one, right? So there's the red one and the blue one. There's a two different, but see the blue one is defined as a 1 and a 0 is a red one. So what is the 0 and 1? Okay, so let's go up, right? If we remember over here, 0 is our card payment and 1 is our cash payment, right? So you can see now 0 is our card payment, this is our card payment, right? 1 is our cash payment, so this is our cash payment. If I can just put one more thing, because I have a habit of putting a grid line. Okay, so now you can see the grid line does look much better. So this is 0 on this one, right? That's the middle of the line. So you can see the highest amount of prediction we have made is the card payment, and you can see the how the card payment look like, and this is how the cash payment look like. So you remember the cash was in a negative, and a positive was on the card payment. If I can take you up again, you can see over here, uh, the positive was the card payment and cash payment was negative, right? So hope you understand how to use the machine learning, especially on the classification model. You are dealing with the classification model. So I would say we have learned one of the machine learning topic, and that was the classifications, and it was a random forest, right? Just a quick recall, right? It was a random forest. And how we did this: first we have imported the excuse me, first we have imported our library. Second, we have imported our dataset. And after loading our dataset, we went through the pre-processing, which was about missing completely at random, missing at random, and missing not at random. Where missing completely at random is about you have to remove all those columns, and in the missing at random you have to look through the distributions of the data, whether it is skewed or it is normally distributed. If it's normally distributed, you will use the mean imputations. If it's skewed distributed, then you will use the median imputations as a middle value. Missing not at random, that's the quite typical one. So where you have to do your survey, or you have to do your quantitative or qualitative analysis again. You have to go through your user or your customer, or your if you're a medical, then you have to go through your patient again, and you have to take more survey from them, right? And this can be solved. So another is checking the rows and column. Then we have checked the information of our data set. Then we have checked the missing value. Then after that we have removed the white space from the white space and the dollar symbol and comma from our amount, right? And after that we have checked the duplicate. There's no duplicate. Then we have did the statistical analysis over here, or statistical analysis, right? Then we have check the categorical columns, and after that we have checked is there any unique value in the each column. There was a lot of unique values over there. Then we have did the exploratory data analysis, which is about histoplot. We have plot the histogram, and we have checked the mean and median. We have checked the distributions through the histoplot. Some are skewed, right? And this also quite skewed because of this area. You can see on this area where median is first, then you have the mean, where mean and median need to be on a same line, right? So this is skewed. And after that we went to a line plot. We have checked our sales, how our sales look like, our daily sales and monthly sales, our monthly sales, right? After that we have checked the transaction, card and cash transaction. So the card transaction was the more transaction as compared to cash transactions, where it was 118% higher. And after that we went to the monthly amount according to the unit sold, how much we are making monthly, and we have realized that on 12th month we are making the double the amount of the any month, right? So that was a great sales on 12th month, right? And after that we have weekly, we have plot of weekly amount according to unit sold, right? So where the highest was 51 week. And similarly we have moved forward to machine learning algorithm. We have imported the random forest classifier, and we have used train, test and split method to split the data into 80% for training and 20% for testing. And we have converted those card and cash payment into 0 and 1 for binary digit to make prediction using classification model. So then we have did feature selection, where feature selection is about selecting the features which is unit and amount, where target is our transaction type, which is our binary digit 1 and 0. Then we did feature scaling, where we converted our mean as a 0 and a standard deviation as a 1. So this help us to train our model fast, right? And we have split the data over here. Then we have applied the random forest model, and we have fit the model. We have made the predictions. After predictions we have the model evaluations. In model evaluations we have used accuracy and confusion matrix. In confusion matrix we have found out like there's a true positive, a true negative, which is like who are using card payment, who are using cash payment for purchasing our product, and false positive and false negative is like that's a wrong prediction on the card payment and the cash payment. And that is the heat map for our truth table. After that, we have went through the formula of all of these: accuracy, precision, recall, and F1 score. And after that, we walked into ROC curved. ROC curved, where after ROC curve we went to decision boundary, where decision boundary shows how to visualize those prediction. So this prediction, right? So this prediction has visualized using a decision boundary, right? So this was our main goal. So guys, hopefully you enjoyed this watching this video, and I will provide this file in the descriptions, and I'm like, there will be a link in the description for this file and the data set. And of course, for any question you can put into the comment section. This video was quite long. I will make another same video on the classification model and the regression model. So next time I will try to make using the neural nets for making more predictions. If you use a neural nets over here, the prediction so decision boundary will be very different as compared to we have used a random forest for making decision boundary. But neural net is more for the big data. So we are dealing with the millions of rows and columns, right? So especially the rows, not the columns, millions of columns. So yeah, hopefully you enjoyed watching this video, and see you soon. Peace.